the voice will not be disrupted. But anyway, so we'll start with the industry and then we'll jump to the academic part. So whenever we hire people, of course, as an industry, we get this opportunity to hire people. What are the first core skills which you look at when you hire someone? Apart from the technical skills, of course, if you want to hire someone for Java, you will test their Java knowledge. Apart from this technical knowledge, what are the core skills you look at in the candidate? So I can start with you, Vivek.
I am the youngest, actually, in this one. So you're starting with me. Okay. Hi, all. Good morning. And the core skills, basically, when it comes to hiring, right? So apart from Java and the coding and other things, I usually see a couple of things. One is their leadership skill. It's the most important skill as well. If you want to grow in an organization or if you want to work with anyone else, you need to have that leadership skill where you can lead yourself. Leadership is not about leading a team, right? It's also about leading yourself. And also the communication skill, the enthusiasm, and whether he has understanding of the code which he is writing. It's not just about writing the code and telling people that, okay, this is the code I wrote, but it is also about explaining why I did this and also explaining why I took this path to solve this problem. So these are the things, and how did we build the projects and other things. So it's not just about the time when I go and interview and, at the time of interview, he writes a code and I see that and, oh yeah, it's good and I'll just hire him. But it is also what past projects he has done and basically understand how much knowledge he has on the project. It's not just about, I wrote something and I took some open source project. I contributed to open source project. Why did you contribute to that open source project? It's not just about, I go and contribute to open source project because somebody told me to, do open source contributions, then I'll get a job. No, it's basically about passion. I found I was using this particular open source project in my project, and I found there is a gap. That's why I filled the gap by contributing to the open source. So those are the skill sets. So leadership, communication skills, your organization skills. It's not just about, going through the technicality of it, but it is also organizing this kind of a festival. Is also a leadership skill. It's also a communication skill. A lot of discussion happen even before starting up this kind of an event, and how people will come up with strategies and solving these problems. I see there is so many things happening here, right? So they are making sure that people are sitting at the right place. All these things, all these skills are very much important when you go into an industry. So I'll leave it at that. I'll let most experienced people to take it over.
Yeah. So yeah, Murli, if you want to add something on that.
Yeah, thank you, and good morning, everyone. The academic part of, the academic performance of every student, we already have the input as, your grades and the marks and what you scored. So that's one, input, and definitely I don't think that we want to spend too much time cross-checking that. However, project work is something that, students experience something different, right? There are things that or you learned that you applied. Other things that you did not know, but you learned on the fly. And there are problem-solving skills, critical thinking skills. How did you collaborate with others, to realize the goal? And of course, communication and soft skills undoubtedly play a major role in accomplishing as a team. So these are things that are, very, very important, right at the beginning. Theoretical study, everybody does that. But as you know, there is theory and there is practice. And project work, whether it is a small assignment for a month or it's a longer assignment for a few months, I think are eye-openers for people to demonstrate, their passion, to demonstrate their abilities to solve problems and apply what they have learned so far. So I think those are some of the things that I sort of look at if I were in a position of, hiring somebody for projects.
Cool. So, Rajiv?
So good morning. It almost feels like a homecoming. This is my 5th time in CRISE. It's always a pleasure. Is it audible? So I'll just summarize what my esteemed panelists say. I'll say there are the 7 C's in terms of the core skills. The first C is critical thinking. So if you're presented with a set of data, how can you apply analytical thinking to solve a problem? And that's something that hasn't changed since the time I passed out of college 23 years ago. And related to that is the second C, which is the C for creativity. Can you, think of ingenious solutions? Can you, do you have a lateral thinking mindset? Did you approach things differently? And we do that when we ask students to solve a problem, or when we ask them to talk about the projects that they have done. The third, as everybody said, it's communication skills. And one aspect of communication, while is about how you present yourself, how you describe your project. The other subtle aspect, and it's a rare skill in corporate today, is active listening. So if you're given a question in an interview, right, we observe and see if people are actively listening. Have they made note of all the points? How are they asking follow-up questions and answering those? The fourth C is C for collaboration. So we are going to work in diverse teams, geographically separated teams. So how can you work with people? That's the fourth thing. And a lot of what we do in college in terms of the activities, project work, etc., is a part of that. The fifth C is coding, and not only how you write code, but how you write good code. And again, related to it is the sixth C, which is core concepts. A lot of times we look at concepts like data structures and algorithms and say, do we really need them? Will we apply them? But we as engineers know that they're just not tools, but they allow you to write efficient code. And the last C, I feel, is the C for confidence. And then confidence is not only in terms of how you're describing what you did, but if you're given a problem, you're stuck, how do you come back? And then confidence is largely based on how well you prepare for the interview. And while these are all things we do assess in terms of core skills when students come for interview, I do want to take this opportunity to leave with a skill which I think is very important for students when they join the job, and which is the skill of patience, to understand that when they join the job, good projects, building skills, building meaningful relationships take time. So when you join the industry, I think patience is a skill I strongly urge students to cultivate.
Oh, that's awesome. In fact, I wanted to summarize, but then you did a good job of summarizing it. The 7 C's, of course, we should have made a PPT before the panelists, right, before the panel discussion. Okay, awesome. And as you mentioned, one of the things about the patience, which is very important, I remember when I joined my first job, so we were getting training for 3 months on different technologies. And then we were expecting the moment we finish our training, the moment we get on the desk, we will start coding on day 1. But reality was something different. So it took us a lot of time to get on the project. It took us around 2 months. Before that, we used to talk to our seniors. We used to get KTs. I am from Mumbai. In Mumbai Engineering College, KT means you are failing 1 or 2 subjects. But in industry, it changes. So that's the personal thing. Okay, now coming back to the next one. Now this is for the academic. Things are changing very fast in the industry, right? I mean, look at the technologies from last 10 years. I started my career in 2010, and I was good with Java, not like an expert. I was good with Java. I was breaking projects. And I thought, I'm smart. I thought, I know everything. My life is set. That's what we think. Once you complete your engineering, once you complete your graduation, you feel, iske baad padhne ki zarurat hi nahi hai. You're done. You're done for your life, right? But then after 2 years, something changed. Or after 4 years, I started working on Hadoop. Then I realized, okay, it will take me 6 months to learn Hadoop. Then I realized the moment I completed Hadoop, people were moving to Spark. Then I left that entire technology. In 2018, something new came into my mind, which is blockchain. I started learning blockchain, and then Bitcoin crashed last year. Now I'm into AI, right? The thing is, if technology in the industry is changing so fast, is it really possible for the academic to go with that pace? And I find it's very difficult for academic to move in that pace. Right? There are a lot of things we have to change in terms of college resources, in terms of teachers, in terms of books, exam pattern, everything. So how do you think how industry can help you in this scenario? How can you keep the pace with the industry?
Okay. Now, as much as you said the technology is changing, we cannot change to that speed, but we change in our techniques. The techniques of equipping students. That is where we catch up with the industry. See, when we run a MCA program or a BCA program or any of these programs, we will not be able to talk all technologies what is available because that's very wide spectrum. But we can only equip our students to say you can adapt to any technology. See, that is the technique we would like to use. Now, how do we use that is right from the setting of the curriculum. See, deemed university has that privilege that every 6 months we can throw out the syllabus and incorporate something new. So that advantage, that we take as a leverage of that, and then every 6 months we introspect the curriculum, get feedback from the industry. That's why our board of studies also has 2 industry experts. So they give us constantly what kind of technology is changing. Definitely, we will not be able to talk about all technologies, but then we will see how we could upgrade our curriculum to make sure that at least the fundamental base is available from where the student could catapult. So that is how an institution would work. In fact, I would say this gap, actually what we are talking about, is pretty narrow in certain senses. Like for instance, communication skill or any other interpersonal skills. We take a lot of effort and we can easily catch up. There's no gap. But then where we see the gap is whether a student will be able to immediately join a job. But as you very well gave us a witness that no student is going to do the job immediately and is going to wait for some time. So we are leveraging on that waiting time to say that within that 2 months, you should be able to get to the technology. See, that is why even though we don't teach certain subjects, within 2 months' time, the students are able to pick up. So that is how we have narrowed down the gap to ensure that students are able to pick up to that industry.
Okay, that makes sense. In fact, one of the things which Sir mentioned, just to summarize it, foundation is very important. Technical skills you can learn in 2 months or 3 months, but if you don't have a good foundation, it is difficult to catch up with the industry technology. Okay, that's great. Now, I want to have the same question for the industry, just for the reverse of it. How do you think industry can contribute to the colleges? So I will start with, you can start, Rajiv.
No, I think.
Okay, you can start with.
Well, lot of initiatives have already been taken on both sides. I mean, industry as well as academia. So, course content, course delivery, and upgradation of syllabus, providing internship and project opportunities of varying durations. Conducting workshops, having an incubation center for startup ideas within the campus. So many things are happening, right? It's all good. And what I want to tell you all people is, you're all in a good space, okay? I think this gap is a little overhyped. Okay, it's not something that should be on your mind. Just forget the gap. Okay, be passionate about what you're doing. Of course, there is nothing like the real world. So when you step out of academics and get into the industry and join a job, there is going to be a big change. So you need to be sort of prepared for it. There'll be a hose pipe of, at full force. There'll be jargon. There will be, techniques. There'll be technologies thrown at you. But, you got to be prepared for that. And for those of you who think, okay, I'm done with academics. Now I'm going to take up a job and, just make money. Remember, if you want to make a career in software engineering, be prepared to be a student for your entire career. Learning never stops. Okay, it is continuous learning. What you know today, you will have to augment. You'll have to keep on adding to it, as Naveen just mentioned. But we should also remember one thing. The fundamentals are always important. Change happens, but it happens slowly. It is incremental, right? Look at an operating system, 40 years ago, and look at an operating system today. So if you learn the principles of operating systems, it is not all irrelevant today. Okay? So, majority and a large part of, what was true decades ago is true even today. And it's true in, all, whether it's software, whether it is hardware, whether it is CPU, what techniques are used to improve performance. So lots of things are carried on, and it all changes incrementally. So if you have a strong, fundamental base, where you have understood the principles, then it's also easy to catch up. Like I said, you have to be lifelong students. And the ability to keep, learning is enhanced if your fundamentals are strong.
Right.
So never forget, that, it's okay if I go from, theory to practice. In fact, I read somewhere, I don't want to name the college, but they have eliminated all these, what they call old age, traditional theoretical courses. And from day one, they start teaching, web applications, and you are put on projects and stuff like that. So to me, that's like jumping from, one extreme to the other, right? There is always theory, there is always practicals. And I would say, as a student, let it be like 70-75% theory. Don't skimp on it. Practical, you'll always get it. And in my experience, most students who join as freshers, within a year, or two, they get fairly, competent. There is absolutely, no issues of getting jobs and being able to contribute to the projects that's been assigned. So, we are talking of just this initial year or, plus or minus few months. And tell me, which profession doesn't have that, right? Would a person who's just got his MBBS, do you want to go and consult him for your problem? If the person has no experience. So in every walk of life, an internship or a training or an apprenticeship period is required. Okay? So I don't think it's any different with the software industry. And, industry should be prepared to put in, the training courses, the induction programs, boot camps, and, all the training materials, make it available to people to upgrade their skills. So I think it's a bit overhyped. Colleges have done, lots of things to improve their curriculum and to provide more opportunities for the practical aspects. And industry is continuing, of course, to invest in training and making them more productive. Where they want productivity from day one, I think, is the services industry, where, the headcount is translates directly into billing and revenues. But I think patience, as you mentioned, is required there too, on part of organizations, not on part of the job seekers. So that's that's what I would like to say.
Right. So before we go to you two, I want to just modify a bit up, because he mentioned a lot of different things, right? So let's say in your team, if you get a new member who just came out from the college, he got hired, and he's in your team now, he or she. What are the things you think is missing in terms of their technical knowledge? Okay, so we've talked about the core skills, right? So what do you think should be a part of a college curriculum? This is what they should learn before joining a job. For me, I feel everyone should know the networking concepts, which they, very famously skip the entire subject. They're like, this is optional. So what do you think, what are the technical skills they need before they come to the job?
First thing, if a new person is there, I'm going to rag them.
Sorry, which one?
I'm going to rag them.
Rag them.
Okay. So to be serious, so see, there is, so from a technicality perspective, right, there will be a gap for sure, because their understanding of technology and because there is a lot of things have been fed to them today. If you just open YouTube, right, this bunch of YouTubers and there's a bunch of people talking about different things. Somebody says, and I get a lot of students reaching out to me, I want to be a developer advocate, because they just see me as a developer advocate and they say, I also want to be a developer advocate. You're a fresher, so you don't get to be a developer advocate if you're a fresher, right? Because you need an experience to talk to customers. You need experience to, if I'm developer advocate, I'm just not doing a talk in some conferences, but I also talk to a lot of startups. I talk to a lot of enterprise customers, and I talk to them with different architectures, how they should be building it better. So it comes with an experience. So you should have at least 6 to 7 years of experience, then you become that role. So there is a lot of things which is missing today. And I agree there is a gap in terms of technology-wise. Even if today, if I ask, everybody knows internet, everybody is using internet. If I just ask how internet works, can somebody tell me how internet works? It's like they'll say HTTP. I go for domain. That's not how internet works. So tell me the process of how internet works. So there is a lot of foundational, also has been missing, and also they will have to go through those different curriculums and other things. So one of the things which I just want to add on top of this is at Microsoft, at least my team works with student ambassadors to build curriculums. So we build curriculums for rest of the world. So basically we sit with the student, we sit with the professors, and we work with professors and students. Basically students build those curriculums with us. So they code with us. So that is where they will learn, okay, this is how we should be delivering a project. This is how we should be using all of these technologies. That's one of the things which is there. And the other thing which I just want to add is, the colleges have to let industries to come into the colleges and teach, as a visiting professors and other things. I don't see in India, very less visiting professors from industry come in and deliver, sessions where they teach new technologies and other things. Because my colleagues in UK, they visit a lot of, Cambridge universities and other places where they go and deliver sessions. So those are the things, couple of things which are missing, because those interactions is very much important. And I love this setup. Basically, this setup is very nice because there is a Java user group. They do meetups anyways. They used to do meetups anyways. But the meetup is happening in a college, and bringing students, bringing professionals and startups and everybody together. It is not about the sessions which is going to happen here. It's also about the interactions which is going to happen after that. So that is where the everything gels out, right? So that's the most important thing. So
Awesome.
Yeah, I'd like to add a few more
Sure.
things here. You said what are the things they could do in the college that's different in the industrial world. So one thing is the scale of things are very, very different, right? As in college you might have written programs or projects, a few hundreds or even few thousands of lines. But when you join the industry, you'll be working on a product with millions of lines of code. And also remember that it's mostly teams that are working on it. And teams are composed of people who each know some part of it, right? Nobody knows everything, the entire details about the whole product. And the beauty of it is how a team where each one knows one small piece of it is able to successfully engineer, build the products, add features to it, and improve it, and so on and so forth, and keep making new releases. So this is something that we are not exposed to in college, right? The teamwork and the multiple roles that are required. Not everybody will become a designer from day one. So there are testing roles, there are, coding roles, there are designer roles, there are support and tech support roles. So each of them have got a certain different skill, which is predominant, right? So if you are in tech support, you need to be, a good troubleshooter. You need to be able to debug very well. If you are in the, in the dev space, you need to not only write good code, you should also be able to read good code, okay? Reading and learning from what is already there is I think, a very important skill that we tend to neglect, because all the time it's about writing code, right? Okay, write this, count the number of bits, and let me see whether you can write in 2 lines of code or 20 lines of code, right? So writing is overhyped again, because you cannot just have writing skills but no reading skills. So reading skills are very, very important. How do you make out? Most of the open source has, a problem with lack of documentation. there isn't always enough documentation that satisfies you. So you have to be able to read between the lines. You have to plug the gap by reading and talking to others who are more knowledgeable and trying to get their information. So multiple roles, being open to that, scale of things, programming in the large, as it's called. This is something that it will be good if there are some team projects, not just individuals, because academia is all about individual performance. But I think exposure to a teamwork and a project that allows people to play these multiple roles and get a sense of it would be helpful.
Right. In fact, when you mention about reading, next time when you copy the code from ChatGPT or Stack Overflow, also read the code first. That's how you start, and then you can read the entire project. Cool. The same question for you. What are one technology or skill, in terms of technical skill, you think a student should learn before joining industry?
I think I'll just add on to them and say the ability to design enterprise. See, there are various aspects when we write enterprise code. There's security, there is understanding a user-centric design. So that aspect of software engineering, which allows us to build skills to design and develop enterprise-grade software, I think so is something that we should incorporate. And I'll just add one more point to what should change in the way industry and the academy is making the changes. I mean, yes, curricula has to change, training the faculty has to happen. But I think the way we assess students also has to change in accordance to how the times are changing, which is not evaluating them on what they have learned, but how they're applying what they have learned. I think so is another area where probably industry and academy should work together.
Yeah, that sounds interesting. In fact, everyone will be with me here when we talk about college exams. Okay, we are in the wrong place to talk about this, but yes, it has to change, right? We have to find a new way. Okay, cool. Now, one thing I have for you is, in fact, before we go here, I have one thing to add there as well. And since you already mentioned this, once we complete our graduation, once we get a job, and of course, Aditya has mentioned about open source projects, right? So you should contribute in the open source. Do you think we should also contribute to the education as well? So as Vivek mentioned, in the other countries, they get a lot of opportunities to go to different colleges for seminars or guest lecturers. I think we should do that here as well. Of course, in a lot of colleges have seen that they are doing it very actively. So every weekend, on Saturday or Friday, they arrange one industry speaker. But I think it should be implemented in all the colleges, irrespective, is it tier 1 college, tier 2 college, tier 3 college. In fact, it should more in tier 3 college, I guess. Right? Okay, cool. So last one for you, sir, and this is interesting, is because I completed my graduation in 2010, okay, and then every year I can see some changes in the students' behavior and the way they learn technology. In my days when we were doing graduation, it was more about learn what you have been taught in the college, make sure that you know everything which is going to become in the exams. And then in the last semester, you have to complete a project, so make sure that you're prepared for that. But I think things have been changed in the last few years. So what are the things you have seen have changed in students' attitude towards technology in the last 5 or 10 years?
Okay. So partly I would like to also respond to the industry. This sometimes is a problem. We hear one side and we don't hear the other side at all as a response. See, when it comes to training the students or curriculum update, just as I told you earlier also, every 6 months we introspect the curriculum and we make sure that everything is available. The latest we try to incorporate. As much as he also pointed out, when a student sits for the interview, the first question is, what is your projects, right? How many projects you've done? Now, that also we are taking care, which means at least 2 to 3 projects, which is part of the curriculum, is completed before he graduates. And apart from that, we also give them ample opportunities for them to work on as many as internships or projects possible. But the challenge there is, who has to give the internship? The buck stops there, right? And it is back again to the industry which says, I can't give you internship, but then you do a project, right? I can't help you, but you do a project. So that is something what I wish the industry also looks into it. Many of our students, when they try for internship, they get a closed door. Then how do you expect us to do that internship? See, that is where I think the industry also needs to change in its mindset that it has to open up for internship. Maybe some amount of resources. You don't even have to give us a space there, but you can give us a problem statement, right? And some kind of hand-holding to say whether the student is doing a good job or not. See, that kind of relationship, when it builds, I'm sure that much of the queries or much of the expectations of the industries also would be met. Now, it is because that we don't have avenues there, that's where the industry and the institutions seem to have a gap. But we are trying our level best to do that job also. As I said, we give a lot of opportunities for students to do their project. Several projects, if you come to with me in the campus, has been done by the students. And we implement not just here. We have 4 campuses in Bengaluru, 2 campuses one in Lavasa and NCR. We make sure that everything is getting implemented. So students do projects which are dealing with 30,000, 40,000 students, users. So scaling up, yes, we do that. But of course, I do admit that it cannot be exactly an industry standard. But then, as much as possible, testing, everything we expose our students to. Now, the other area which I wanted to talk about is how we go about inviting the industry people. Now, as Vivek, he mentioned that people are not invited to give lecture. No, that's not really true. We do invite. In fact, we wish that many industry people spare their time and they come and take classes. 2 things are possible. 2 things are becoming a hurdle. Number 1, time. The moment we call them, the issue is with their time, which we need to accept. I don't deny that. The second is the pay, right? No institution in India will be able to give a corporate pay. Right? So that is, again, I expect, as from the institution point of view, that industry need to be a little more liberal, right? Ready to send people to train us. Now, in spite of that, how we go about bridging the gap is, very often we have industry connect program, like this program. We very often we invite guest lecturers and they make them teach. As much as possible, we try to at least get our alumni back into the campus to teach. In fact, almost all our projects are actually evaluated by their alumni. The point there is, it is not the alumni which is important, it is the industry experience which is bringing us back. So that is how we are trying our level best to help the students to mature to that level. So this is our expectation.
Yeah, so just to answer that, the college, the Christ College, I think it's privileged to have the expertise of great teachers and great management. But unfortunately, in India, we have a lot of colleges where we don't have these options. And maybe they are not even trying to solve this problem. So I can see the great efforts going on in Christ College. Cool. The question for you is the changes you have seen in the students.
Yeah. Of late, in fact, we don't call ourselves teachers because we have changed our role to be just facilitators. The reason is, ever since pandemic hit us, more and more online courses, more and more students' ability to learn on their own, right? So, and we foster that. We help them out. And we say, fine, you do that, right? We would only try to facilitate. Of course, we teach some of the fundamentals, but then we also consciously make them learn on their own. And I see that many students have got this ability to do self-learning. Now, for instance, the video what you saw, I'm sure that none of us have taught them, right? He has not picked it up from the classroom. From where did he pick it up? It is his passion which has driven him. It is his passion that made him to make sure that all that we did is give him an opportunity, right? We created a platform. So that is a bigger change of attitude I see, that students are ready to stick their neck out and start learning on themselves, not waiting really because it's too difficult. Now, also we have to understand that the classroom has a lot of imbalances. We are not getting just one set of students who have only 90 plus. We also take students who are slightly weaker in studies. So we need to make sure that balances are available. But at the same time, when we identify students who have good potential, we give them the freedom to exercise. So I see that many of the students have started getting interest to learn on their own, equipping themselves. So platform is available, they start building up. That is how we see that when they go to the industry, very quickly they adapt to the latest technology, and therefore it is so.
Awesome. So I think we had a great discussion regarding the academic and the industry. Still, there are certain things which we need to clear out, which we'll do off the panel. So once we go outside, maybe in the canteen, we can have the same discussion. And I hope it was helpful. Thank you so much, the panelists, for being here and answering all my weird questions. Thank you so much.
Thank you, our esteemed panelists. So this truly was an insightful discussion. We got a lot of inputs out of this. Bangalore Jug has definitely made note of it. Like Vivek said, this is not going to end here. We will take back all of these things and see how we can help you students, the future professionals, get the best out of this. With this, we end our combined events. Before we split up into the industry track and the academia track, I will just take 2 minutes to express my sincere gratitude to all our supporting partners. Without them, we wouldn't be here. And I would also like to thank all our distinguished speakers who very graciously accepted our invitation to come and speak here and share their expertise with the community. I must thank all the organizers who have been working very, very hard for the past 2 months to make this grand event a big success. Finally, I would like to thank you participants for taking your time, coming here and proving that there is still worth in community. I truly encourage each of you to embrace this opportunity, attend the enlightening sessions, and have more talks outside. So with this, thank you everyone. I now have some instructions for you guys before you move out. It is that all the confirmed student registration participants will be moving to room 911 after a small short break, and you're in good hands today with Naveen. He will be taking care of you, while all the students and the professionals who are confirmed for the industry track, please come back to the main auditorium after taking your snacks. Lisa will now help you out with the instructions to step out. Thank you everyone.
Thank you, ma'am. All students, kindly note, please do not use the side doors. There is refreshments for each of you. Kindly use the main 2 doors at the end of the auditorium to leave. All the CRs are requested to escort all the students of your class outside the auditorium and maintain decorum. Please make a single line to leave out of the auditorium. Also, all the CRs are requested to hand over the attendance list to us so that the attendance for these 2 hours can be put. We also remind the CRs to put the attendance for the next 2 hours according to the permission letter given to you all. Thank you.
Hello, I'm audible. I like mics with I can move around, but that's fine. Okay, so we are. I can see definitely today I am going to tell you the problems with the fragmentation, but that's not good here. Okay, so that's fine. I mean, it's some people like backbenchers. I also prefer to be in the backbench. That's perfectly fine. Okay, but fragmentation have a problem in software engineering. We must be knowing that. Okay, so let's discuss. Are we expecting anyone else? Jayshree? Okay, she is one. All right, so I'm going to talk about the scaling up your Java application. Hoping most of them are from industry and very few college students I can see here. Okay. In fact, I have made my slides much easier for the college students to understand. So, can be a trivial slides for you, but let's go through it. I am a JVM engineer. I was working in Sun Microsystem. In 2005, I joined the hotspot team. I mean the JVM team, and then I joined Oracle, and then right now I'm working in Salesforce, and I'm still a JVM engineer. Okay. What JVM engineer do is it's a good tag name. Actually, they don't do anything much. So we just keep frightening people like things will not run good. You are not running right parameters, all those kind of things. I'm Bangalore Jug leader from 2006. It's been quite long. And now I am grateful for all the people like Jayshree and Satish who have taken the Bangalore Jug. All right. So, how many of you here are the Java developers? All of you? Okay. I mean, better question to ask how many of you are not Java developers, but fine. Okay. Java is kind of 1995. It's an old language. It's one of the oldest language. Not one of the oldest language which is still doing great, but yes, it's one of the very old language. And Java is pioneer in many things like, the garbage collector. The garbage collector first came into the Java peripheral, and runtime optimizations first came into the Java. And suddenly, Java is 1995, and till 1997, it became a very super hit language actually. Okay. And it's still doing good. I mean, most of the Python developers will not agree with me, but yeah, thank you. Okay. Hello. Yeah. So, if you have a question like, what are the things that a language get changed? So, generally we do lot of meetings and lot of discussions with like processor developers like Intel and AMD. We do a lot of meetings with OS developers like Microsoft and Linux community and all those. And then we discuss like what are the problems they are facing. Okay, what are the supports we need from them as a processor level or from the operating system level. Okay, so they are all very highly integrated. Don't think like a language don't leverage the features which are there into the processor or the features which are there on the operating system. Okay, so we try to, suck up the best out of everything. Okay. Yes, maybe I'm working in Java from a very long time. So that's why I can say like it's still one of the languages which is highly scalable. Okay, and there are many examples of that. I mean, I remember like Twitter. Twitter when it started with a very small application, and slowly they need to go for a very high level of escalation, right? And they moved on Java. Actually, I don't want to say that what language they were before, but when they were not able to scale up the application, they moved later the language on Java. Okay, so very, very easy to scale languages like Java. Okay, and Java future, I really don't want to comment much. Okay, but it looks solid still. Okay, so let's this session be a little interactive. Okay, and we will discuss actually. I have only 45 minutes, but still we want to discuss. So application scalability is one of the biggest challenge that industry is seeing. Okay. And many people here who work like for big applications like e-commerce, anyone who is working in Flipkart or Amazon or Salesforce or any of the big e-commerce application, you can understand that how troublesome is to scale the application. Okay, so I want to hear from you. You need to be loud. That say like, okay, this room can fit like maybe 500 people. Okay, what will happen if I'll try to fit like 5,000 or 10,000 people in this room? I mean, it's just a scaling problem, right? So I want to know from any one of you. The AC will not work properly. What? Suffocation. Yes. Yes. That's right. Where people will sit actually. You will fight with each other. Okay. Overloading. You guys have learned object-oriented language very much. What is that overloading? Okay. Anything else? Out of space. Out of space, yes. Anything else? Movement of people will take longer time. Okay. Okay. Yeah, with all this problem, we will not able to serve the purpose. Okay. So this is the same problem. What happens that you started with some website or some Java web application and you are like 100 customers right now. Tomorrow it will be 1,000 and soon it will become millions and billions, right? And then like all the government site, you will see that sites are not running and you are hitting 404 and all those kind of things. Okay, so scalability can be done by many ways. The first, it should come by design. And a lot of people I see, Murli was also talking about the design and the programming language and data structure. So design is one of the most important thing, which comes in a very early phase. You need to believe yourself that tomorrow I am going to have millions of customers. Okay, if your mindset start with like I am going to have 100 customers only, then it's fine. I mean, no one can help you out. Okay. And the second thing is that development, which is like the coding part, which we are going to discuss in little bigger, like how the coding changes the scalability of the application. The third thing is optimizations, which is provided by the complete stack from processor to operating system to language to your framework to your programming language. All do optimizations at their own level, okay? And they all try to do best and they try to run your application in the best way, okay? And the last is infrastructure, okay? And infrastructure is the last resort. If you will say like, I want to scale this application and I am going to make this room large and I am going to add more seats into that. I mean, people will reject your solution. They will tell, no, that is not possible. Okay, I cannot make this room large. Fit 5,000 people here only. Okay, so we will discuss about infrastructure and we will discuss when to increase the infrastructure. But if you will directly go to someone and say like, I need more CPU, I need more RAM, I need more heap, they will straightforward reject your application. Okay, the first 3 parameters you have to fit perfect. Yeah? You have any questions, you can ask me anytime just by raising your hand. Okay, so solution by design. Let's understand very few basic things. I am not going to be too technical here. So one of the best design solution is loose coupling or no coupling, right? I mean, one of our friend here said that we will disturb each other, something. You were saying, right, sir, that we will disturb each other. Okay, now you need to be loose coupled. You need to be zero coupled. I mean, you should not disturb the nearby person. Then you think that we can fit more people here? Right? So loosely coupling is one of the solutions. If you are not disturbing the person next to each other, or your code is not disturbing the code next to each other, you are perfectly fine actually, right? So loose coupling have many benefits, you know, multi-threading, you can apply as much thread as onto the loose coupled code, right? So, and that's called the art of being stateless, okay? So stateless means like, we all need to be stateless actually. Just finish your work and keep going. Don't try to put something which is not required into the memory, into the database. Don't try to save the state. Don't try to pass the arguments unnecessary from one place to another place, right? So, it's a very strong review system that can figure it out, okay? But generally, for the review, we look for like the shortest distance people, right? So we'll just tell the next bench guy that, can you review my code? And right, he will just go and press a button and done. Okay, so that's not how the industry review happens. Okay, we have worked in OpenJDK, and it's too complex to get even a small trivial code to be reviewed in a JDK world. Okay, I mean, they will just bomb blast you with like 10 times more than what you have written in your code. And what I wrote is that your architect or whoever is the designer of your application need to remind the team every day that your review system should be good. Your code should be stateless as possible. Okay, it is not possible to be stateless all the time. Yeah. Fault tolerance, right? So I have given an example, right? What will happen if a transaction fails? Say like you are making an e-commerce system like the Amazon, and the transaction failed. What the Amazon system should look like? Any answers? Please? Intuitive. Okay. Intuitive means the transaction have failed. Sorry for the inconvenience. Is that kind of intuitive? Huh? Retry. Retry in the statement or actual retry? Rollback. Oh, you are still into the database world. That is gone long before. Okay. That is like 15 years before. There is no rollback and all concept is gone now. Okay. Now we make sure that we sell the same item to 2 customers. Okay. And then one we return the money and one we give the item. Okay. We are working on different level now. Please, louder. Compensation. There is no, those mic are wired all. Okay, you can take this.
No single point of failure.
Okay. It's just fine. Hello. Audible? Yeah. Good. Thank you. So basically what I was asking is from the coding side, that what if the transaction fails? What if the download fails? What if the connection socket fails? What you should do? You should have a fault tolerance, and that is called retry. Okay. So most of the applications that we develop, actually if there is a download that fails, it will retry. It will retry for 2 times, 3 times, 4 times. Okay, there will be a threshold set for that. Okay. Intuitiveness is gone. It's a long old history that I cannot just tell that, oh, this download failed, you need to retry it again. Okay. So we need to write a code or we need to write a script which will be fault tolerance. Yeah. The last part which is very important is modularization by design. You all know the module systems, right? So modular codes are, it's very tough written in industry. Most of the people, I mean, they just talk in the theory. They don't really write a module code. But the good framework actually force you to do so. Okay. So people who use a lot of frameworks to develop like Spring Boot and all, the modularization and all will be a framework force to you. Okay. And what is the meaning is that one module input and output is good enough for the another module. Okay. I am not really going that, hey, what you have written there. Okay. So it's like, okay, this is the input of this guy, this is the output of that guy. Other guy should just see the output of that particular module. Okay. Don't try to go inside what it is written. Yeah. So these are the few solutions which are by design. You should try to make your application. I mean, you should think before even start writing code for your application. You can ask me question anytime. Okay. this we are going to talk a little bit more. So solution by code or by development or by whatever you want to say. Okay. So we are looking here for the solution at like all the software life cycle, and we will see that how they can solve. So right, by code, anyone, I mean, don't see the slide, that how you can make a scalable application. I mean, today you have 100 customers, tomorrow you will have 1 million customers. Who was that person? Multi-threading, yes, multi-threading. Algorithm should be optimal, yes. Okay. Load balancing, who said that? Okay. Load balancer is actually an infrastructure thing. It's not a coding level, yes, but yes. Load balancing is one of the important things. Anything else? What in the data structure and algorithms? I generally get scared when people say data structure. I remember all my interviews. Okay. Concurrency, yes, that's right. Multi-threading concurrency. Okay. Really, no one is for parallelism here. I mean, concurrency is a beast. It's a very complex thing. And parallel things are much easier, right? Is it not so? I mean, in place of one door, I will just open the 4 doors and I will tell people to come inside. Is it not so? Concurrency is not so easy. Concurrency, I have to put a guard there and I have to tell that, man, if someone came inside, you should just close the door. Okay, so concurrency will come later, but parallelism come much before than concurrency, right? So one of the solutions, the best solution is like, you should write parallel code, which is multi-threading, precisely one of the gentlemen have said here, right? And the multi-threading, there are many ways to do multi-threading in most of the language, but most of the language you should leave onto the standard APIs to do multi-threading, okay? I mean, you really don't have to go and discover the whole wheel again, that I will write my own multi-threading code, okay? I will show some of the example, like I will just take like Java example and say like I will run a simple streams into the Java and I will just do dot parallel, and then you should see how the parallel streams work, right? And it's a pure one word of code change to make it multi-threading, right? And parallelism, you should know that the data on which you are working, first of all, that data need to be splittable, right? Like people entering into this hall, is this data splittable? Yes. Because you all have to occupy different seats, right? Doesn't matter that you are entering from that gate or that gate or this gate or this gate. I can just open all the gates and I will say that, come inside. So in programming language, I will say like make 6 threads, where all the threads represents a door, right? Just go inside. I mean, if you're sitting on each other, then it's a different problem, but should not happen like that. Okay. So let me run a simple code. Is it visible? Okay. So all the people who are like from the Bengaluru Jug, these codes they have seen like 100 times and must be very boring for them. But what I am doing is that I am doing little bit complex calculation where I am finding the area of circle. So math.pi, A equal to pi r square, right? And then what I am doing is that first block I am putting it into normal stream, and in the second block I am adding it into the parallel stream. You can see here. Let me dark it for you, right? And I am also posting that how many number of processor available on this machine, okay? So that you can guess the timings. So here it goes, run. So, oh, this is not visible, is it? Okay. So, my machine, which is a company box, that's why it has 10 processors. Okay. Generally, corporates give a very good laptop. So, So, output is same for both the values. Like, you should not get confused. I mean, that is 3.591 something something is the output. And you can see if I'll go sequential, then it has taken 3074 milliseconds. Whereas when I ran it parallel, it took like 392 milliseconds. Can you tell me what fraction is that? Is it 10 fraction? Really? No. Don't be so confident. If it is 10 fraction, it should be 3920, the upper one, right? Okay. Ideally, it should be 10, but there is nothing called ideal in the real world. Okay. So almost like 8 times better job, right? With 10 code. And you should not be sad that, oh, where the 2 cores have went. Okay. There is a lot of management work that parallelism have to do. Okay. So why I showed you this code is just to say that parallelism is very simple. Okay. And where it used, we almost use everywhere in the modern industry, right? The Hadoop, you are doing a lot of background jobs like scanning the paper or doing a lot of cron jobs. Everything use actually parallelism. Okay. Any questions? Everything is very simple, I can understand. So, if you have attained parallelism very properly, then you should come on to the concurrency, which a lot of people said, right? And concurrency is little complex. Anyone can tell me the difference here between a parallel application and a concurrent application? Not the Bangalore Jug users. Parallel don't need to be synced, okay? And concurrency need to be synced. Okay. Race condition, yeah. Okay, then concurrency need to be used. Something more, straightforward. It's still very complex definition. Yes, if you are sharing resources, it is concurrency. Okay. That's right. Right. So actually what happens that when you are running similar kind of threads or similar kind of work, that is called parallel execution. And when you are running different kind of work into your processor, like your 3 threads is doing different work, your 2 threads is doing different work, that is concurrency. This is at the very bottom level. At the top level, actually, when you are using a shared resource and you are trying to get into the shared resource, you need to use concurrency. It's very simple. Okay. So as sir told, like concurrency have a lot of waiting time, and any guesses that why there will be a waiting time for concurrency? Locks. Okay. Locks, yes. Okay. And what if will not lock? Race. We all like race, right? What is the problem? No? Okay. Okay. Data corruption? Can I say? Yeah, I mean, in the end, you should say something which is quantifiable, okay? You should not say race condition. It's not quantifiable. What is the final effect is that data will get corrupted, right? Your bank balance will get corrupted. Okay. So, concurrency generally deals with a very complex formula. Actually, it's not so complex, but if you try to understand. Okay. Concurrency is basically, concurrency or parallelism, it get impacted by 2 things. Okay. One is called the computation job and one is called IO job. Anyone have doubt about it? What is computation job and what is IO job? Computation job is like purely mathematical job, like what I was doing in that code, like finding A equal to pi r square, right? And IO jobs are like connecting to database, connecting to the HTTP client, okay? Anything where the IO is required. When IO is required, actually, what happens that the CPU says that I am free now, okay? There is no load onto the CPU because it's like a background job or it's a less priority job, right? So CPU will be free for most of the time, okay? So how to deal with that? Application is too complex. You don't understand like which jobs are computation jobs, which jobs are IO jobs. So you need to figure it out. Okay, you need to figure it out. That, do my image is all about, do my application is all about image processing? Yes. If your application is all about image processing, it's a high computation job. Okay, image processing is a total computation job. All right. Is that I have to save image to the disk? That's a IO job. Okay. Is that I have to go and take the request from somewhere? It's a IO job, right? Now, who know your application? Definitely I am not. You know your application, right? So you need to figure it out that what are the IO jobs available, what are the computational jobs available, and then how to manage the number of threads. Okay, here I have given you an example. Don't get into the details, but number of thread creation depends upon how many cores you have. So say like my laptop had 10 cores, right? 10. Into utilization, how much CPU you want to utilize? Should we utilize 100% CPU? No? Yes? Why you guys are so embarrassed saying no? Yeah, no. I mean, I really don't want to kill the CPU. If you are using 100% CPU utilization, your CPU will like burn out. Okay? So yes, every industry have a standard set like 40% or 60% of CPU utilization. Okay, if there is a more than 60% of CPU utilization, they will have a red flag. Okay, I mean, we have a whole team who is sitting and just watching this all things. The time it will go to 60%, doesn't matter, it is 2 o'clock midnight, you will get a message. Okay, that your application is not doing well, you should also not sleep now, wake up. Okay, so those things are like part of job, nothing to worry. So I will take 60% of utilization. Now 1 plus wait time divided by compute time, it's very simple, right? Like the whole idea is computation. That means your wait time is 0, computation time is 1. So whatever is your core, just create that much number of thread. Depending upon the utilization, I'm taking it 100% right now. Not true. If your wait time is very high, say like it's your wait time is infinite, how many thread you need to create? Whatever you create, it will not be fulfilling, right? Your number of threads need to be infinite if your wait time is infinite. Your CPU is kind of always empty. So what happens? It will be somewhere in between. 60% computation, 40% IO work. Okay, so on all these values, you should create the number of threads. You should run your application. You should try with some more data. Okay, and then finally, you have to reach to a solution. We language developers cannot provide a solution for you. Why? Because we don't know the application server. Okay. I mean, language developers have just developed a generic solution for you, right? So you saw that parallel stream I ran right now where the Java thought like, it's a computation job, let's take all the CPU and use it. Okay, so you saw the application running like 8 times faster or maybe 9 times faster. But that is not the truth case in most of the industry. You just want to run 4 times faster or 5 times faster, yeah? Okay. And the last line is like, theory is just a start point, right? So you have to do the work to believe. Any questions, any doubt? Okay, good. So what happened that this was kind of synchronous model where like when you start doing IO job, actually your thread will be blocked. That is called blocking of a thread, right? So we will say like, boss, this thread is blocked. Let's put other thread for the job, okay? And that's why the number of thread need to be higher when it is a blocking work, right? So we came with the concept of asynchronous thread modeling, okay? Asynchronous thread modeling is like think like a restaurant, right? When you are into the restaurant and say like waiters are there are some 10 tables, right? Now I will send a waiter on 1 table and I will say like, boss, still that guy will not give order, you stay there. It's a blocking, right? You are just wasting the time of the waiter and here people are chit-chatting and they are checking their WhatsApp and they are like saying, hey, this item is not good, this item is good. Someone will say, let's order this. Someone will say, no, we won't order this. And that waiter is like seeing your face. Okay. So that is typically how the synchronous system work. Okay. You are blocking a resource. You are blocking a very valuable resource. I mean, waiters are valuable resource in terms of restaurant, right? So asynchronous thread model say that you just go and attend the problem and then say like, you guys decide till the time I will come back. Okay. But the problem is that someone else can come back. It will not be you who will come back. So those threads which will be empty will come back, right? So that's an asynchronous model which is very good, very effective, but there is some problem into the asynchronous model. Anyone can vouch for it? Okay, that's a very good point. Anything else? So you are saying that thread need to communicate between each other, yes? It will come back or not come back, that's a problem. Very good point. Yes? Anything else? Stateless. Can you please elaborate? Exactly. Very good. Starvation, yes. What he said is precisely starvation, that the thread will come back or not. I mean, that's a question, right? There will be, I mean, yes, you can say the most of the thread will be like leaving the job and like they are just idle. Okay, possible. Okay. Yes, so the biggest problem with asynchronous is like the same thing what happens into the restaurant, right? Like you explained something to the first waiter and then the second waiter came and I mean, you will tell like, I already told you this, and this guy will like, no, tell me from starting. Okay, so there is a callback mechanism, right, where the thread need to communicate with the next thread. Okay, and it becomes complex. And you know, in the software industry, we say something like thread dump. You guys know, right? Thread dump. Thread dump becomes very complicated because it is not one thread which is dumping it, right? So on your particular problem, actually, there are 4 threads who have worked on. So now I need to get the thread dump of all the 4 threads. So the debugging becomes very, very challenging. Okay, because you will not understand that what is going, which thread is attending the problem where. But in the end, actually, the application performance will be better. Okay, but if your application will go bad or go down, you should be ready for your weekend job. Yeah. Okay. So in Java recently we did something extraordinary. That is, we say that the JVM said that we will handle the asynchronous model. Okay, so programming language don't have to handle. By the way, there are a lot of frameworks came in between this asynchronous model and the new thing which came into Java. And those all frameworks or programming model actually say that we will create asynchronous model for you. You really don't have to worry. Okay. Now Java or JDK itself claim that you really don't have to worry. Okay. So they called something called virtual threads. Okay. Where the Java is saying that we will create the thread and we will see that how to synchronize and asynchronize the thread. You don't have to worry. Okay, and the thing is that you have to just change one line of code. In place of thread, you have to say virtual thread. That's it. Okay, and the performance will be damn better actually. What we are still not into the production mode. We are still like into the multiple testing modes. So, but I have few small codes where I can show you the performance. Right. So it's visible, and right now I have said that virtual thread is false, right? And I am creating kind of 5 lakh threads. I mean, you guys are comfortable with lakhs and all, right? Not the million billion guy. I feel a lot of people feel very embarrassed saying like lakh and crore. I mean, it's fine. It's our nomenclature. You can say that. Okay, don't be so embarrassed about it. So I am not using the virtual thread right now. It's false, and we are creating kind of 5 lakh threads. Let's see how much time it takes. And I have given some kind of small work for it to do. Okay, nothing much to worry about it. So yeah, sorry for that. I have not written milliseconds. So it took like it took like 15 seconds, 15616 milliseconds. Okay. What I will do is that I will say like just run with the virtual threads. Okay. Means now it's not the operating system thread, it's the JVM threads. Okay. Yeah. Okay, and now you can see, oh, this screen is visible. Now you can see it took like 1 to 1 millisecond if we are creating virtual threads. Okay, so you can understand it's a massive difference in the time. Okay, and now these threads will take care, and you really don't have to worry about that how the JVM is doing. If you are finding any problem, just throw it to the JDK guys; they will fix the problem. Okay, and definitely you have to pay them. You can use open source JDK, yeah. Then you have to fix yourself. Huh? Okay, so this is one of the benchmarking we did with the virtual threads, and you can see in the normal traditional thread when the concurrency is going from 100 to 200 to 1000 to 2000. Now the transaction per second is not increasing after a certain limit. You are seeing it is becoming 199 and then let it be 1000 thread or 2000. In fact, the 2000 thread, the transaction per second is reducing out because your system is not capable enough to handle those kind of threads. Whereas if you see the virtual threads, you can see the TPS is continuously increasing even if I am creating the number of threads much higher than what it is required, right? Okay, so don't ask me that, okay, what is the drawback of this? Okay, that you have to go and figure it out. Last time I remember, I was giving virtual thread presentation somewhere and he said that, no, you cannot get all these things in free now. What is the drawback of this? Okay, no drawbacks. No, that is not possible. Okay, so here are the things we discussed the solution by code. So you should be good in parallelism, you should be good in concurrency, and there are many good things, writing good code and all those kind of things. I'm not going to discuss the good boy concept. Okay, then the next concept is solution by optimization. And you know, here also you have to do a little bit of hard work. Okay, but the underlying language will do most of the work for you. So you should just, sir. Virtual thread will take care of the concurrency. You are saying asynchronization. Yes. Yes, virtual thread will take care of this. Okay, I have not showed you the demo because my time is very less, but see, here is the demo, right, where I am sending the thread for a sleep of 1 millisecond. Okay, and now what will happen if I'll run this code and I will see the compute CPU monitoring. In the virtual thread, you can see the pressure is too less because the thread will go and the thread will see at the time it will see the sleep, the asynchronization code will come out. Okay, it will not block the code. Okay, sleep is actually a block, right? You know, thread.sleep is a block, right? Yes. Is the time over? Is it? Yeah. Okay. Let me finish it fast. Questions we should discuss on lunch. Okay, a few of the things which I really very close to, and Firoj is here who work on all these things. So the garbage collector optimizations, if you are all from industry, you know what is garbage collector. JVM do a lot of internal optimizations like the runtime optimization. It takes care of all your SIT code and it will optimize it inside. Okay. So some of the GC performance which we are putting, right? So you can see like if you are moving it from the older JDK to the newer JDK, you can see there is a boost in the performance, right? And that we always say like you should always be onto the cutting edge technology of everything. Okay. Fortunately or unfortunately, Java don't force you to come onto the JDK 17 or JDK 21 or like that. But if it is your operating system, they will run your auto update and they will tell, no, you cannot stay on this. If you are using Python, where most of the people know that it will break into the next release. Okay. Unfortunately, Java is actually it's a fortunate thing for many. Java is the only language which can support the backward compatibility. And it supports still JDK 1. Actually, we have still so many jars who are sitting on like JDK 3 and JDK 4, and like it's from the legacy of the grandfather to the children and to the grandson, and like it's going on. Okay, and the jar is running perfectly fine. Okay, but if you are doing the fresh development, you should always use the latest of the technology. Okay, so throughput, you know, latency is also very high. You can see with the newer JDKs. Okay, pause time also you can see with the newer garbage collector. The pause time have went very, very down actually. That is like 0.1 millisecond. That is the pause time we are looking out. Okay, definitely the memory usage will increase with the newer versions of JDK, because whenever you try to reduce few things, the few parameters will go up. Okay. And the last thing which I want to discuss is solution by infrastructure. No one likes that. If you will say I will increase my infrastructure, I want to improve my infrastructure, let me tell you clearly, no one is going to listen that. Okay, so never give that as a first solution, that I need more heap size. That is what the industry do, right? I mean, if the JVM is going out of memory, they will go and increase the heap. It don't work, right? So this is the typical workload these days we are seeing, like in the Kubernetes pod and kind of Docker pods. And you should create more replicas of those pods rather than going and increasing the heap size. Okay. So yeah, fix of the perf is so increasing heap size. No one likes it, but all do it. Okay. Increasing the number of replicas, no one likes it, but everyone do it. Okay. Use another stack, means go from the Java language and use something else. No one likes it and no one do it also. Okay. They will stick with whatever the programming language it has been written from the ancestral property. Yeah. And as one of the persons said here, the load balancing. Can you raise the hand, sir? Yes. Load balancing is very important thing. And load balancing happens that who is paying you more money. So you should balance the load as per that. Okay. If there is a highly paid customer, you will give more bandwidth to them. If there is a less paid customer, you will give less bandwidth to them. Okay. So depends upon here, though I am not talking of the bandwidth, I am talking about the JVM size and replicas, right? So there are two topologies that you can take: more small JVMs, many replica, or larger JVM, less replica, depending upon what suits good to your application, right? So you have to do a go work. Right, I am on the last slide. Scaling is one of the most complex problems of the industry. We cannot give extra resources, whereas we cannot afford downtime also, right? Amazon claims 1 millisecond downtimes claim them $5 million US. Okay, 1 millisecond, I'm not saying 1 second. I mean, how much we do shopping, it's ridiculous. Scaling should be part of all software lifecycle phases, okay? Profiling, monitoring are very important when you are doing a scaling up your application. You cannot just sit on the theory and can do the scaling, right? Scaling may give you a worse result than what it was giving now. And a few examples I have talked, like Twitter I have told, there are many other examples, okay? So you should look for the scaling examples, okay? That's it from my side because we don't have extra time, so I will not go for more codes and shows. Any question, I can take it down. Last question. Yeah, this is what happens. I will give you the resource and it will be of no use. Just like that. Okay.
Let's say virtual thread. We are using the virtual threads, and then we have some other dependencies as well. So will we be able to use the virtual threads with the same dependencies, like let's say some other jars we are using to connect to the database or stuff like that? So will they be able to take the advantage?
No, they will not. Virtual thread is an API level change. You need to understand it's an API level change. If it's a jar which is already made up of some code, where it's written thread, not the virtual thread, it will run with the normal classic thread model. Okay, so you take that jar, you get the class out, you take the code out, you make the class again, you make the jar. No, you should not do it. Okay, so it cannot leverage that jar. Okay, so new development can be done, but the old developments, old jars thrown somewhere, it will use the same classic model.
So kind of, let's say, we are using the dependency to connect to the database, the example I'm giving. So there has to be some development and the new version has to come up with...
Exactly. When actually application developers are the last people. So it starts with the operating system language, then the third party tools like you are using JUnit, you are using some kind of other jars, right? The third party jars. You are using a Spring Boot jar. So those guys first need to actually use the virtual threads. Okay, and then it's your application who has to use it. But I can assure you that application servers, framework developers, they always use the cutting edge technology. Okay, they will, most of the Apache Lucene, Apache Tomcat, Hadoop, they all work with the latest Java. I know that much. Okay, and they use most of the latest technology by API also, not just by the namesake. Okay, so yeah, it's the time for the application developer to look into the problem.
And one more question is, from which version is this coming? Like the virtual threads are being going to be available?
Okay, from JDK 19, the virtual threads are there. It will be production ready in the upcoming JDK, maybe 6 months or a year time. The Oracle tell me not to tell the time, so it's fine. I mean, it will be ready. Yeah, thank you. Sorry, I'm late. You can catch me after.
Thanks a lot, VC, and apologies to both you and our audience because we are running short of time. Definitely note down all your questions. You can catch hold of VC at the Bangalore Jug booth. Now I have Raja Nagendran here. He is CTO of Tejasoft. He is famously known as Code Doctor with his over 20 years of experience working with around 2 billion technical debt code. So he's here to present a very interesting case from Amazon. Over to you, Raja sir. And kindly keep all your questions, note down. We'll have Raja sir later and you can ask him.
Hi. Close to good afternoon. Thank you for the intro. Yeah. Hello. Yeah. Yeah, basically, I want to talk about, I think a lot of, speakers also talked about how do you handle large code. And this is where I think, one of the speaker also mentioned that, most of the enterprise applications are millions of lines of code. So how do you handle it, very effectively? And that's where it is coming out from some of our, cases where we work with the customers to recover them. This is where there is a term called, you must be seeing it as an enterprise monolith, but slowly, you will start hearing it, enterprise monoliths are nothing but monoliths. And then how to extract advantage of serverless, that's what I will talk about. So now you see the trend in the architecture also, where, everybody talked about serverless, and then, microservices, CQRS. Now slowly the trend is modular monoliths, which is actually equivalent to how do you handle large code enterprise applications. But unfortunately what happens is, whatever the technology comes, if you misuse it, it is not enough. That's what the other side of the picture is talking about. And we also heard about AWS where they talked about, serverless, actually costed them very high and they are going back to monoliths. So please make sure that, I will try to give some contradiction here. Not that serverless is bad, something else is bad. If you can take away that much information from this talk, I think, we achieved something through this. And any company, if you really, I think Vaibhav also was talking about scale. Scale is a must for every developer. In spite of, what OS and platform does, even, when you are developing an application, you should worry about how do you scale your application for millions of customers when they start using it. So unless that mindset is not there, I think, we end up with, functionality. We keep firefighting, in the production. So, but NFRs, non-functional requirements, have become all the way more important these days. And if you really look at any enterprises, they have applications, and not just one application, multiple applications. And this is where, we talk about how to bring the scale using modular monoliths as well as serverless. And that is again because, you don't want to sell your premium product for one customer and then, expect him to pay the full money. We want more and more customers, and that's where, the focus has to be scalability, so that, we are able to lower the cost and bring in more and more customers. And I am talking in the context of, he was talking more at a platform level. I will talk more about application level. That way, if you really dissect, application, you have so many ways to meet the scale. Or, you may have to do not just source code. You have to worry about dependencies, what he was talking about, Spring Boot, JUnit, whatever, you use third party, you should worry about them. And then you should know how to configure them, and then how to have a hardware also appropriately, so that, you are able to scale better. So this is where comes, the terms called, monolith. So now we know the trend is definitely serverless, as everybody knows, has some, people have realized that, that's not the way to do it. But they are trying to go back from monoliths. But I would say it is neither serverless nor monolith, it is modulith. And then serverless also has, will still be relevant with the technologies like IAC. How many of you know about IAC? What is IFC? Anybody knows about IFC? Okay. I'll cover that. And then, there are some, once you code it in a certain way, then there are ways, which actually dissect your application and deploy it either in serverless way or a Docker way. So that way, you only code once, but rest of the deployment can be handled. That's the very latest from Google. So now coming to, let's see now how do we move from, monoliths to moduliths. This is where, I think I should have put our Sriharikota Chandrayaan 3, but anyway, by that time my slides were there. But you really see that a giant thing, we should say it is not about serverless is bad and monolith is too good. But you need benefits of both. The same thing, if you want to, build a Shiva at such a giant way, you cannot expect a developer to go to every part and then create eyes part, nose part. No? So you need to find a way how to dissect it. So this is where, though it looks very easy to develop and easy to deploy, easy to test, you will still face the problems of handling large code, which can be maintainable. And you can definitely, when you have a support system to build it, you need large hardware, which is also not right. It will not be cost effective from the maintenance as well as, from the hardware cost. So now a simple example of how the large, files are handled in a file, in any office. You see that, there are certain ways of dissecting it and then organizing them, so that, we are able to easily identify, and then we don't have to carry all of them. So this is a very simple example where you are still a monolith, but you are able to handle the complexity well. And the same thing when it comes to software, you would see that you can partition the team by a technology, either as a front end, back end, or now you have micro front ends, which are vertical slicing. So none of them are enough if you don't adopt them properly. So now when it comes to the team, yes, we have two options. When it comes to the code, we have too many options. The first one we know is monolith. Second one, I think we have seen the transition, SOA, where, inter-applications, how do they communicate in a unified way. And microservices, macro services is where monoliths fits in. mini services where, there are some business domain payment gateway like that, you still treat them as an application, but separate them as mini services. And microservices is always the hype. And nano services, this is where actually the serverless, whenever somebody says serverless is bad, actually I think, they are referring to how do you write a code so that it gets deployed in serverless. And that's called nano services. Most of the time, you know about, function as a service, lambdas. So that way, we should always worry about, I think, whenever somebody says serverless, please map it to the code as nano service or a pico services. So this is again, another representation where you see that, same thing. If you want to both good code base and good team, then you can combine it this way. One of these, you can have team per module. And examples of that, if you want to have a general insurance in a monolith way, I think there's one application which will serve all the kinds of insurances, whether it is a house, cars. But if you want to go in a monolith way, we say, okay, I have a separate application for vehicles, homes, business, and travel. That way, if you go to mini services level, at least you set kind of policy, and then based on that, you build an application for that. So when it comes to nano, actually, that's where you correlate, you have a CRUD level up, services, which is very, very difficult to tie them up. So you can also see that, when you partition it, one is a partition and other is how do you assemble them, how do you integrate them. So that in monolith, you see, number of connections are required are very, very less. And as you move towards serverless, these connections increase. And that's the real complexity of serverless. And if you go more deeper, you will see that serverless is function as a service as well as a backend as a service. And tying them is becoming very, very complex. And I think, that's a very logical. Amazon said that as a chattiness and all. In summary, I would recommend monoliths. You should start with startups if you are really good about it. Product which is supposed to be proven. Move toward, SOA, I think enterprises are already doing it. Microservices as you scale your customers. In return, I think, the bigger way of, classifying that is 0 to 2 million, try to be monolith. And if you want to go beyond, try to be modular monolith. And then that's where, based on your revenue, you map your architecture. Don't go by hype. Now, once we know that, there is a space for serverless, there is a space for monolith, there is a space for monolith, how do we really, what are the technologies and tools which have come these days? And that's where I talk about, a non-modular application can be very, very, a monolith which is non-modular can be very complex to manage because the dependencies, if you see, is too much. But if you can control the dependencies, that's where modular work comes in. And some of this modularity, I think most of the developers may be already aware, where at a binary level, you reuse different frameworks. And that's where, you see dependencies is one of the ways how you are actually becoming modular at the same time monolith advantages you're taking. I think most of you may be able to correlate it, Maven, that these dependencies are coming for you to use others' intelligence as a part of your application. That's a binary level modularity. And then, on an application level also, if you have, multiple modules, you can recognize them by multiple POM files or multiple build.gradles. So that's also not, I think people are talking about even that is also very complex to manage. They want to get to single source. And this is ID level also. You can see that ID also supports a lot of modules where you can define its own class paths, its own source paths. And the real trend could be that, I think the ideal thing could be you should be modular at a source code level. And we know some of those constructs already there, which is nothing but you say public, Then, at a class level, you can reuse. Protected, still constrained. Package level, still constrained. And you can have private inner. But actually, that is not enough. That's what, and I think Spring has come out with something beyond this to help the developers to be modular. So now if you really see source code modularity at a functional level, I think this is mostly at a modularity at a class level. Then you can also see modularity at a function level. That's where you see a lot of lambdas, Azure functions. All of them are trying to say, how do you be modular at a function level? And then this is where I think a lot of focus is now coming in. The traction is, I think class level and function level is, they have a limited support or they are very hard to stitch. And that's where there is something called package level modularity, which we also know that if you have a solution where it takes orders and inventory, how do we take advantage of package level beyond public protected? This is where I'll demo you one. So this is, I think, I'm using the Spring modular framework, which is, I think, very latest, I think 1 or 2 years old, which can alert you if you are actually going back to, if you are missing the connections between too many packages, and then if you have cycles, all that, if it can be controlled at a compile time, then automatically as a developer you are more safer to convert monolith application into serverless. So this is, I actually now everything is modular, so it will work. I will break the modularity and show you that, it fails to, it fails. So you have a, you have a class where, I have 3 modules, domain, inventory, and orders. And we want to make sure both of them just use, inventory and orders can use domain. And we want to enforce that, some kind of, no cycles between orders and inventory. So now if I break that, I don't want anybody to use events. Then you will see the same application will complain saying that it is not modular enough. So now that's what is, now beyond packaging and beyond inherited, protected, you are getting a support from Spring that, be modular, being a monolith guy. So like that, there are cycles. I can show you the I can actually correct it fast. So I just want to make sure you understand what monolith is. It is a class level, a group of classes at a package level, and then they go beyond to enforce certain rules of cleanliness. So now I can actually see even the diagram, what is the dependencies. If you really see it, I have an application, both of them depend on modular. One guy listens to it, other one depends on it, directly calls it. Other is, through the event it is able to associate. That's what I think, one of the things you should, all of you go back and then start focusing on Spring monolith package. So far clear? Okay. I can't hear you. Okay. See, one day actually comes from, see, this is again a good practice after analyzing lot of products. And at the end, we are mapping it complexity with revenue scale. So otherwise, there's no point in talking about, unless you want to reach India to America, then there's some way you have to change your strategy. And all these technologies are evolved over a period of time. Trying to kill them does not mean that, the purpose was very clear that at some point the old ones were working, at some scale they are not working. So if you really see that kind of track record, not that one is replacing other, but when the context of the business scale changes, then you have to think about something more. So that's all. Now one side we have seen application, other side now there are two parts to it, right? From my talk, serverless is one side and modularity. At least I hope modularity all of you would have understood by now, that we are trying to make the developer more modular so that he's not left and right using the API. With the intent is that, the second part, how do you manage the deployments as serverless? And that's where if you really see the hardware partitioning. So we have seen the application partitioning. Now it's the time to see the hardware partitioning. We started with servers, now VMs, containers, and serverless. And if you really visualize them, you will see that like this, where you have hardware, OS. The virtualization talks about a VM level, and containers will talk about Docker level. And the same thing you will see it much more granular way. So basically, yes, I wanted to see, to get a scale, you need two parts of it, application scale and hardware-based utilization. But though hardware utilization, can that be software, the infra side can we do something? And that's where serverless wins. So that way, please always think about, how do we do best hardware partition and best application partition? And when it comes to the hardware partition, you will again see that, we have come to a level where we all understand YAML. You give what you want, all the dependencies related to the application as a configuration. And that's where YAML we are all know. It is trying to stitch application with dependencies with the hardware. And so, we also know about, what actually combines, partitioning of application as well as partitioning of dependencies. That's where we know it as DevOps. And that's where you see YAML file. You will see developer side, we talk about continuous integration. And operation side, they want to deploy it always. And the name given for stitching in the DevOps world, can anybody say that? What do you mean by stitching of all these complex applications at scale? Okay, I think it's very popular with Kubernetes. Orchestration. So you want to make sure that you are able to remove some VMs or add some containers, whatever the way based on the load. So that's where, and I think now the trend I could see, maybe it is still 10 years advanced. You have seen monolith application, microservices, serverless, and coming to your point, we are blaming monoliths after 10 years or 20 years of using it, which means it has worked at certain point of time. And what of that context is mostly the scale. So that we know, whenever you are adopting new one, know why the old one also worked, whether it has really earned enough revenue or not. And maybe the trend could be that, I don't want to even worry as a developer, I don't want to worry about whether it is microservices or serverless or monolith. Let some tools manage it. That's where the hybrid application, maybe you should go and see Solo Glue, which is trying to support multiple ways of gluing any kind of application. And yes, this is an example of YAML where you see config as a code. I think the IAC is all about, infrastructure as a code. You will start coding how my infrastructure should be. Where this is where I show you an example, instead of saying, asking operations team, give me S3 buckets, 3 S3 buckets, you can actually code it like this. Why? That way, it has become, hardware has become an API for you. Let me see if I can. This is the last example I have. So what this application is doing is, it is creating three buckets for me. So now you see the best part of DevOps I see is hardware has become now software, truly software, which means developers have to be much more, they have more load. They were only now worried about business logic. Now they should also know what about coding, operations logic, which is the hardware. So that we know, I think in fact, somewhere I talk about, developers' role is increasing because, somewhere, it is becoming easy, somewhere it is becoming more complex. You can see now, it has actually created 3 S3 buckets. I don't know. Maybe network must be there. Otherwise, it would have not created. So that way, start focusing. If you want to be a good, modern developer, treat operations as a software requirement. No more, it is not like a hardware anymore. It is a software for you. Anyway, I think network is slow. I can also delete it with one command. And this is where Pulumi is. I'll talk about some of the latest, frameworks or, where which are the enablers of cloud as a code. Yes, these are the ones. Pulumi is one thing I think all of you should really look at it very seriously. Because I know Terraform is also there, but I think Terraform is trying to give his own language, but now everybody wants to do it in their own language, and that's where Pulumi excels a lot, where you can write it in Java, Python, doesn't matter, and this is all evolution. But I would see DevOps in one statement, the 10 years or 13 years of DevOps, it is trying to becoming a software code. More code, not less code. And the real thing now, see, that is also people are not happy because now I am writing a functional code, which is a business logic. I am writing a separate hardware logic, which is infra logic as IAC. But the real problem is my functionality keeps changing rapidly. And then matching these two can become a very complex. And that's where infrastructure from code comes in. So infrastructure from code is exactly about, why don't you write it as a meta instructions within the code base so that let the tool figure out how to write a IAC code and execute it. And this is where I think, this is still very far, but it has already come. There is a lot of traction. Look at infrastructure from code so that, you are actually, having a modular code at the same time, including infrastructure code. If you remove that function, you don't have to go and maintain IAC code. So delete it, it is gone. So you see that Clotho persist, it will actually knows that, now it has to actually span a persistent store. And then, you don't have to worry about writing explicit infrastructure as a code. The difference between IAC and IFC is, you don't have to maintain an explicit infrastructure as a code. And these are the frameworks where you see very well. They're still infant stage. I'm not saying they're in the prime, but IAC is in the prime. But these are the frameworks I would request you to look at it, watch out on. So in all, what we want to say that is, so you have to scale your application, yes, beyond operating system, beyond frameworks. You should worry about how to deal with millions of lines of code. And that's where, still try to partition the code in a modular way, single. In fact, the good trend, we also have heard about mono repo, but people also are talking about mono build, which means you just have one build.xml or form.xml or build.gradle. Because see, unless you really control the code properly, there is no way you can achieve the scale optimally. So worry about partitioning, worry equally about stitching. And the stitching part is actually infra part, where you should see how you can write it as a program rather than as a configuration. See, I know people always said DevOps is configuration, but that is not enough when you really have a complex code. And the last part of the stitching, I think what Google is trying to do is give me a monolith modular code, which has got very clearly defined what it consumes and what it needs. I will deploy it the way I want, and that's where you see they say that you give me module A, module B, and then I will decide how to deploy them in any cloud in any way. So Google Service Weaver is actually a 1 month old, I think. Maybe, I don't know, internally if they had more. But I think, the industry is moving towards making either deployment. I think, developer don't have to worry about deployment, but if you follow certain rules of monolith. So you can deploy it on one machine, you can deploy it on multiple machines or multiple processors. Let the tool handle that for you. So in all, what you should take from this is, develop and debug as a monolith. I think, start with monolith and try to refactor it towards monolith, and let the infrastructure be handled by IFC, and then let the tools do the rest. That's what I have. So any questions? So far.
As soon as our audience saw us, they knew I'll not allow them to ask questions. But
Sure.
Kindly please note all your questions. Raja sir also will be at the Bangalore stall. Do bug him. Thank you, Raja sir.
Yeah, thank you.
I now call upon Satish onto the stage. We have Satish here. He is CTO of our Kadai. And in today's Javafest conference, he's wearing multiple hats. He was one of the seeder for Javafest idea. He is a speaker here. He's top core organizer, also an educator in recession sessions. So, and Satish is known to serve technology in terms of bhajis and bondas. I'm very eager to see what analogy he's going to give today. Over to you, Satish.
Definitely no bhajis. Bhajis are only for microservice talk. How many of you attended that microservice session? Okay. So it will not be that entertaining. We'll do something informative. I'll try to do something informative. Okay. So this talk will go a little randomly only. Same rule, meet up our conference. Stage is different, but the methods are same. Any of you have any doubts, you can ask here, or you can ask after this, or you can ask in any Bangalore jug. We are here to answer your questions only, so don't hesitate to ask any questions if you have any questions. Okay. So this talk is more of a research talk, so I'll go that way. It will not be like I turn on the technology or something like that. It will be more, sometimes I need to take some history, stories and all those stuff, so bear with me. And as I keep always saying, history is very important. Whether you are studying in college or you are studying in technology world, history is very important, because it's history who gives us problems. And because of that problems, we go and find solutions. And the solutions become technology. So it's always, if you look at even real world, right? People who read history, they will be ruling people, right? Same way. So if you want to rule your technological world, always pay attention to your history. So with that note, I will start with today's talk. So this will be more like a discussion. How many of you part of this digital transformation journey in your company? Okay, so even though we put different names, I would say digital transformation from enterprise side, it's very simple. It's between Java connecting to a relational database. We connected from Java to Oracle, and then Java to Postgres, Java to MySQL. Maybe you'll be changing those, but most of the time you'll be, many of the digital transformation projects are around this area. So this area is very important because whether we like it or not, You interacting with relational database from Java, it's a very common area that you will continue to do even in future, where even though there was no more hype about NoSQL, but at least people are now finding ground with relational databases for their own good. We had a separate talk, we'll go to that in detail later. But one, I just want to keep it again, relational databases are coming back, and they are coming back very, very strong. And same way that NoSQL movement happened, now there will be SQL movement also happening. So it's like people go upwards and then they will come down. Same way, people go to monolithic to microservice, now they will come back from microservice to monolithic again. It's called modular monolith. So I just want to keep two things related to frameworks and technologies. Frameworks and technologies, I cannot say something that I say today is valid tomorrow. Not like any human values. Human values, be good, do good, that is always valuable. But with the technology, that's not valuable. We'll go to an example later. And also, your solution depends on the tools that you have. For example, if I want you to travel from here to, say, Hosur, if you have bicycle, that's a different story. But if you have motorbike, then it's a different story. If you have a car, it's a different story. It's a tool which decides the solutions. So these are all the two facts that we need to consider. Why we consider that, we'll go later. Before we go into the detail, we'll go one by one. So I'll just go with history, what happened with these persistent problems with persistence. So very early days, thanks to Raja. Raja gave that first option here, that is ODBC. Any of you started your career with ODBC? ODBC? Okay, very few. Okay, all senior folks. Okay, so I started with JDBC. Just 1 year later, that's it. So when we started interacting to relational databases from Java, first we had this option of ODBC. On those days, you need to install software to your machine, and then only you will be able to connect your relational database. That is how it all started. Because of that installation, that time there was no cloud. People used to carry CD. They go on site just to insert the CD into the client machine, just have a star hotel stay for another 1 month or 2 months. Now that on site is no more logistics, right? We just do it everything in the cloud. So this ODBC was at that point in time. But it was quite difficult to install and all those stuff. And then came JDBC. JDBC is actually supposed to serve as portability tool, where you use the same methods to connect to multiple databases. But we need to watch this portability word with JDBC. This portability word you should not confuse with the portability word that you use today in ORM tools. ORM took this portability into a next level, altogether a next level. JDBC gave an option where as a Java programmer you can connect to your database, but still your SQLs are not portable. If you have written some SQL that works in Postgres, it will not work in MySQL. That time even the standard was not there, and that was the problem with us. Then till at that point in time, there was no problem of tools or frameworks. It's all native Java. But then it started with the first set of frameworks. If you are coming from banking industry, most of you are still will be using that. There was connection-based frameworks. The problem with JDBC is, so we gave an interesting terminology. I don't know whether it's a right word or it's a parliamentary word, but he said idiot-proof. JDBC was not idiot-proof in the sense, if you open a connection, you need to properly close the connection also. If you open a result set, you need to close the result set also. Otherwise, you will have a lot of nightmare, right? And people are lazy. As we grow, or as we become more technical savvy, we become lazy. That's part of it, right? You have mobile, you become lazy, right? Same way. So people are not doing their work properly, and that's why connection-based utilities came, where you can execute the query and they will take care of opening the connection, closing the connections. Even today in banking system, you can see that there is a strong connect to that connection framework. They are coming back again. I will go to that later. But now with the current generation, so now I'm coming to the current generation. In the current generation, all this that I talked about are not at all an option. You will be either working with an SQL mapper or an ORM. How many of you are working with Spring JDBC or MyBatis? Okay. So you all work with SQL mappers. How many of you are working Hibernate? Okay. Majority. Okay. Why this is majority, there is a history also. That I will go later. More the history, it will take a lot of time. But between SQL mapper and ORM, SQL mapper takes a side from database. So for example, if database is this side, SQL mapper takes a database side, which means you can execute anything that you want from the database. All that SQL mapper will do is they will map an SQL into result set. and you can do whatever that the database takes. But the side effect is you still need to write your own query. Now ORM took a different approach. It took a side. It said, I will take a side of Java. So from the Java world, ORM says you map a table to class. You map a row to an instance of an object. Then I will do rest of the things. I will do all the magic. But if you do lot of magic there, magic will become a black magic that many of you might have experienced, that will go. So now, what you need to understand is, people had no other choice apart from taking a side. So one side, if you are taking an ORM side, always there is it's all about balance in technology. If you gain something, you lose something. It's all about more gains, lesser disadvantages. That is how we make the choices. So with SQL, even today, SQL mappers are coming back now again strong. The reason being, there are considerable amount of changes that has happened in the industry. So far, of course, beyond this, there was lot of small disruptive things happened. For convenience sake, I have not put it here. I will explain that later of the stage. But consider that these are the majority of reasons why actually digital transformation happened. Now, when I'm talking about digital transformation, I'm just taking two case studies. One is Meta transferred from MySQL 5 to MySQL 8. And another publicly available information, DBS Bank migrated from Oracle to Postgres. Now, one commonality that you see every time somebody migrating from one to another, it's not 1 or 2 days of a job. It's an year-long plan. If you go and look at those white paper, you will understand. Because it cut across multiple teams. So if you are upgrading, you need to go through that pain. That is a usual thing. So our talk is going to be about what are all the pain points that we can avoid from that. That is the idea. Which one? Yeah, I'll come to that. So, mostly, when we talk about our discussions usually in our regular work stops with discussing about frameworks. Angular is best or React is best. Spring is best or Quarkus is best. But I would always recommend you go one level down. Look at the approach. Because it's the approach that decides the framework. So, now we will go even one level lower. The more that you go into the depth, you will get the future prediction little better. That's the idea. Now I will go even one level down. I started with this. Actually, it's a wrong place of starting. I intentionally started with it. Can someone tell me what is the push factor for, first of all, approach? Changing an approach. Changing an approach, as I told, it will take years. And every company is not going to do it just like that, right? It's going to cost them huge money, huge coordination effort. If they are changing an approach, there should be a valid reason. What would be that reason? Mostly cost, but business. In one general business. It could be security, it could be cost, or whatever it is. For example, we all talk about electronics vehicle is the future. Why are we talking about it now? Because we have drained all our petrol resources already. Now we are talking about electronic. It's not like electronic was not available earlier, right? Electric vehicles are available, right? So it's business who decides that. That is the reality, right? So I will go one level down. We will go to the business-wise what went through in the over this. This is like 15 years, this is what happened. So now we'll go through what happened. When we all started software industry, we were writing projects. Projects in the sense, I will go to, say for example, because I will write a software for them. I will go to Flipkart, I will write a project for them. So it's all projects. And slow projects were relatively smaller projects. Till that time, this JDBC approach was good. But slowly, projects become bigger. We started working with people like, I'm talking about 2005 or something like that. We had team size of 200, which is very, very common. So larger team size was a very, very, very important factor. Now, if you consider this larger team size, with larger team size, you will not have specialized resources. And that is why ORM came into picture. Because with ORM, once you map it, after that, everything will be taken care by ORM. Right? Then we started doing products. When we started doing products, what was the inherent need from the product is, every product, the customer used to say, in my company, I have bought license of Oracle. In my company, I have bought license of, say, for example, MySQL. So it is the company's license decided the portability requirement, not technology. It's not technology which decided I'm giving portability, come and use it. People don't use that feature as long as they don't need it. The need came because we got into the product culture. And these are all the factors that everyone that you see came into the market. Okay? Now, the reason that I'm considering all this past is very, very important because only when you know past, You can predict the future. We'll go to the prediction later because we should not, for example, many people do data science without even doing data engineering. That mistake we will not do. First we'll do data engineering. We'll get the data in the proper shape, we'll quantify the data, we'll have enough quality data also. Then we'll go. Okay. Now, hope till this much it is clear. It is the business need which got the solutions. Right? So probably today's business need is a little different. That is what we are going to see at the end. So now with that, I am just going to consider what are all the things that changed today, because we need to accept that these are all the things that is changed. Then only we can accept that the approach has to be changed. Without that we are preaching approach, nobody is going to look at it, nobody is going to be interested in it. So now there are two things that you can see. You can check the brand new ORM tools that are coming today. There will be a common connect between all the ORM tools. What is that common connect? We will see. So before we go to that, let us consider today's scenario. In today's scenario, I want to just consider three important factors here. Point number one, I think people can see this. So point number one, we started doing SaaS products. We started doing SaaS products. We are still doing products, but we have started doing SaaS products. Now, one question that we need to ask ourselves. When product came into picture, what was the need? Portability was a need. Now, when we are changing from products to SaaS product, is portability still a need or something else is a need? Scalability. At that point in time, as a business, I made a choice. Say, for example, one customer is using Postgres, another customer is using MySQL. So, just to bridge the gap, just to keep both of them happy, I need to compromise on the quality. Now, in SaaS world, who decides the technology stack? It is you as a product owner decides. It's not your customer. Because of that, portability is no longer a case, but rather how much I can squeeze from my underlying solution is the important factor. So it's all about getting better performance, better security, better features, better maintainability is my intent, not the portability. That is one. Okay? Now, cloud microservices are highly, DevOps are misused word, but I will just take cloud as a very simple example. Cloud is nothing but renting a computer instead of having your own computer. Keep it that way. Keep it that simple. Now we are getting to the cloud era. What change that cloud expects? Robustness, okay. Scalability, okay. But one specific word, maybe I will put another question. Sometimes, right, if you don't get the answer, you go to a different direction, you will find an answer. What does this native compilers do? GraalVM. We all claim that GraalVM is cloud ready. Why we are saying GraalVM is cloud ready? Boot up time, startup time. Okay, why startup time is less? Compile natively. Very good point. Okay. Any of you from front end side? React.js, Angular, or you are aware of it? Okay, you are aware of it, that much is sufficient. Now in front end side, something is happening for cloud native. They call it as static site generators. Hugo, Jekyll, what are they doing? All that they do is, whatever rendering that you want to do, they will do it right at the compile time, get it, put it in the CDN. So it's like this. If you have your own machine, you don't bother about startup time, let it take its own time and all those stuff. But when you are paying rent to somebody, you want it to start quickly, use less memory and all those stuff. For that, what people are asking is, whatever that you want to do it at the compile time. No reflection, no runtime optimization. Correct? And that is the place where the native compilation that we see today, GraalVM or static site generator. Now let us come to the Java world. Just look at certain new tools that has come. For example, Dagger 2, or the most popular one would be Dagger 2. There is something called Juke. Juke. How many of you are using Juke? Juke. Okay. J-O-O-Q. Okay. What is the significance in Juke? Type safety. And how is it getting type safety? Whatever that you compile, it will compile and create the code, correct? Yeah. So, very simple logic. People want to create everything, make a parcel and deliver it there. It's like you get the parcel from Swiggy rather than you go to the restaurant and order it. Right? That is what cloud influences us. And the third point, which easily people sometimes overlook at it, and that is what I think the most important point. Evolution of RDBMS. RDBMS has gone through a drastic set of changes. Few years before, RDBMS were strongly questioned for two reasons: because of their scalability limitations, and point number two, they are very strict. They are structured databases. Because of that, people went away from relational databases. But now they are coming again to relational databases. What is the two reasons? Two reasons is, point number one, today's relational databases are highly scalable. Whether it is Google's Cloud Spanner or AWS supported Postgres, they all scale themselves. You don't need to put any effort. But the second one is very, very interesting. Now people are saying, I'm going to relational database because they are structured. People went away from relational database because they were structured. People are going to relational database because they are structured. Why is this conflict? Experience, right? So, same way that I can relate is, around 2003, Spring, Hibernate, everybody saying, we are highly XML supported framework. No Java code, it's only XML. After 2005, Spring Boot was not that. Spring and Hibernate changed their approach. They said, no XML, we are completely Java frameworks. Why? Because in 2005 or somewhere, Java 5 came, which brought a feature called annotation, which gave a better way of doing meta programming. Right? That is what I told initially. JPA became a standard after annotation. So it's like the tool that decides, like I told that motorbike example, right? It's a tool that decides. Now, we need to look at the tools. Only when you look at the tool, you will be able to make the possibilities. Okay, now with all, actually I know that this is a little bit extended introduction. I think it is needed because what we are going to talk about is it needs a different mindset. Now combining these three, what we expect today is, whatever that we want to do it right at the build time. And when we execute it, we need a better performance. We don't want to take a choice. We don't want to take sides like database side or ORM side or something like that. That is the idea. With that note, I will get into this compile time ORMs. There are many compile time ORM. One that I'm showing is a research project that we started at Bengaluru Java User Group based on the feedback that we received from Bengaluru Java User Group. Consider that SQL component is one of the compile time ORM. There are a lot of other things also. But at the same time, in SQL component, we are doing certain things which we figured out that the modern day compile time ORMs are conveniently conveniently missing it out, and that we want to incorporate. So these are all the three challenges. So these are all my upgrades that you need to consider. Hope everybody agrees. These three are not smaller things. This takes years. Correct? Right? Okay. We will see that at the end. Whether it takes years or not, we'll see. Relational databases today, one is that, and then type is safe. So these are all the common frameworks that I explained. All people need control in the compile time itself now. These are all the frameworks. When you find time, go and look at them. Diesel is from Rust side. SQLC is from Go. Juke is from Java. I think this is CGSQL from Meta. They open sourced it in C language. Now there is commonality between all the four. So they all do the compilations and keep the code right at your compile time. With that, I just want to go through a small demo. After the demo, we will continue again. But I just want to show how the developer experience will be once we get into these kind of frameworks. Over to you, Haripriya.
Hi all. So we are going to look at a demo where I have a small application. It's kind of a book my show kind of an application where we'll be booking shows, viewing list of movies, or selecting something. So here, what I am having here is like simple creds alone, not much of that. So here we are going to look about this SQL compiler, which I have with me. So before going on that, what I'm doing is I'll be adding this SQL compiler to my pom.xml, and this is the compiler Maven dependency. So after that, and this is my data dictionary where I'm representing my database connectivity rules, and what are all the, for example, the mapping logic I'll be representing here. So for example, when I'm going and compiling my database, And I sometimes need to give certain rules where, for example, if I need to exclude audition files or read-only fields, something like that. So I can add them here. So this one tells the insertion map where I'm specifying that the created date must always be equal to the current timestamp. And again, another rule is for update map where the modified date must be again the current timestamp. So this is my data dictionary, and again, this specifies our database connectivities. So with this compiler, what will happen is, once I build my application, and what will happen is that in my target folder, all my model classes, repositories, and SQL DSL files will be auto-generated, and with the help of the compiler. So what that makes is that the size of the code is generally being decreased. With the help of this, you can see that I've built my code, and you can find that the model file is being generated, and the movie manager is also being generated. This movie manager is the one file which includes all the SQL operating queries and things. So these are all being generated with the help of the SQL components compiler. Okay. So after building my application, I'm just going to start with my basic applications here. So this is the application file where I just have two statements. One is a simple insert, and that which returns what record is being inserted here. And again, I have a list of movies in a CSV format, and I'm inserting them as a list of data. Just two methods here, nothing more than that. Okay. So here what happens is, my compiler provides me with the facility of fluent SQL DSL kind of coding. That is more of declarative style of coding. So that which makes us the coding a bit easy for the developers. So also this compiler provides us type safety. For example, this is an insert statement where the title is of data type string, and it won't allow me to enter anything in other data types. This is a small example for that. So this throws me an error. So this provides with type safety here. And also, this compiler gives us optimized mapping, and all these operations are based on the flow of our data type. So this is what is happening. So after running this code, let me debug it, and I'll show you. Before that, this is the movie manager file that is being compiled with the help of our SQL compiler. And so this is the movie manager file. This file consists of all the SQL queries which are being created. So here is the query for insertion, and similarly here is a query for returning, and here is the query for all these things. See, these are all the queries, or these file is being compiled and generated by our SQL components compiler. So that's it. So I think after debugging, so here I was SOut. I did an SOut for the select query here, and this one, as it is an declarative kind of coding, what I can do is I can get suggestions once I have this. So here, these are all the fields which I have in my movie SQL. So this is, if I'm going to check a query or check the IDs, I can go have it, and these are the suggestions being provided for that. So either an ID can be greater than, or it can be equal to, or greater than or equal to, and these are all the options which my compiler is providing me. So with this, here I'm just debugging this select query here. So you can find I have picked for the movies which are directed by James Cameron, and I have just 2 records of that. So this is what has been displayed here once I debug it. So this is done with the help of SQL components compiler. So that's it with the demo. Thank you.
Thanks, Haripriya. Hello. Thanks, Haripriya. So, this talk is not about the full features of SQL components or compile time things. This talk is about something that we need to see after that. But before I go to that, have you all noticed what is the change that has happened now, right? It's all being done at the compile time. And the type safety, I just want to go again with the type safety here. So if you look at it, the moment you do a compiler, the code that is being generated here, it is not depending on any library the moment the compilation is done. This is why I related this with static set generators, right? There is no JavaScript here, it's all HTML. Same way. So, one that automatically will happen is performance. You still have the type safety that you experience with your JPA. In fact, the type safety now goes even one bit extra. With Hibernate, how do you write custom queries? JQL, but you will give a string. We'll give a freestyle string, right? Now, just let us just look at this SQL that is being generated here. So this is that SQL, right? Now, two things that you will notice here is every time that you select one, that if you send a wrong type, for example, if you don't give short, it will not allow you. Right? Because it's a short. Similarly, when you are doing a select query, if you observe this, here this rating is what? It's a number. If you put a dot, you will see greater than, less than, greater than, equal to, less than, equal to. If this is a string, what are the operations that is allowed for string in querying? Either equal to or like. That is all that you will see. So this and all, once you use it, you will know. But let us go to the actual part of our talk. Now, one thing that I told, it is a solution that decides how much of a problem that I can solve. Now I'm just going back to this upgrades problems that I had. With this compile time ORMs, do you guys see a logical place where we can solve our upgrade problem a little better? Any guess? And I think this is one point that even not other compile time ORMs are claiming, but it's actually the possibility, but that has to be explored. Okay. Now, when you are doing the compile time generation, what are the things this compiler considered so far? Two things. One is your type. That is what it validated. Other one is the sequence of operation. Sequence of operation, technically it is nothing but a builder pattern. So it uses a builder pattern for SQL. That much it verified. Let us just take this one level higher. So now whatever that Haripriya showed, you see this returning statement here. Why returning is required is in a typical enterprise application. Every time you save something, what do you expect in return? Every time you save something, what do you expect in return? The record that is being created, right? Usually that is done with two queries in a typical way. One is the query that is going for insert statement. I hope all of you can see this. My screen is very small. Okay, you can see it. So another thing is another query that is being fired here. What is this query is used for? What is this query is used for? To get the record. I inserted it, I am getting the record. Okay. Now I'm not going to make any code change here, but my company decided that I am using little old version of what is it? Postgres. I'm using 10. So now my company is saying, can you upgrade to 11? Between 10 to 11, Postgres added something called returning class. What is a returning class will do? Returning class in Postgres. So Postgres added, it's now standard feature in SQL itself. This is being part of Oracle also now. This is added with multiple databases now. So with returning class, when you do an insert, you can also say, see, I'm doing an insert, give me these items returned in return. Okay? Now can you connect where the optimization can be explored? In our case, returning case, instead of 2 queries, we can make it as 1. But for that, the developer doesn't need to put any efforts. Because with SQL, not just SQL components, compile time ORMs, you are not coding, you are doing metacoding. All the coding that you are giving is your data dictionary file. That is this mapping and all those stuff. So now all that I did is I did not make any single line of change. All that I did is I upgraded my environment. Now I am just going to repackage it. Now when I am doing repackaging, what will happen? It will compile. It will generate the code. Now we have added this intelligence to the compiler, where the compiler is checking which version of Java that your program is running, which version of Postgres your program is running. That intelligence the compiler will have. With that intelligence, so when compiler generates the code, let us look at the returning now. Let us look at what has been generated for returning. Okay, I thought it will not work, demo worked. What do you see? Yeah, we changed the database version, right? Okay. What was the problem? Okay. Let us look at the Docker compare file. Okay, my infrastructure is not updated. Thanks, Haripriya. So I stopped it, removed it. Now I am starting it again. So my infrastructure is now changed to Postgres 11. Now I do all that I ask is now in clean package. Now this gets us a very interesting problem that you don't even consider it's a problem. Every time some library changed, as a framework owner, I need to balance it, right? I will say Hibernate supports minimum version is 11, minimum version is 17. And if, say, Dhananjay is using 19, I am using 17, both Dhananjay and myself will get the same code, which is not fair. With compile time ORMs, we get that, even that problem solved, because when the compiler compiles, it understands what Dhananjay's compiler will do, what is that environment that Dhananjay has, what is the environment that I have. With that, now let us just look at the new one, which I have not put any effort. It's not my code. It's not our code, by the way. Now you look at it. Do you see the improvement here? 2 improvements. Point number 1, if you look at your query, at the end, you are having returning all the records. So my returning is already coming. Now it is no longer an update. It's no longer update. So I will get my result set directly. Here you see, I will get my result set directly from this one. This is just one. But the point here is, with this compile time ORM, where we are trying to go is write once, update every time we run a build. It's not like update whenever there is a time comes, whenever the need comes. We have the right to upgrade whenever the infrastructure teams is upgrading, either a JVM or your underlying database, we have the right to upgrade. And that is the place where these technologies are taking us. There are some interesting other possibility with transactions and all those stuff, because with this kind of flexibility, we can rethink our old problems in altogether a different manner. And that is still to be explored. Hopefully, this area will be explored further, and then we will see the benefit of this technology also in future. That is the idea. So hope this was clear and it was informative. Thanks, guys. Any questions? Please, you can contact me anytime, or I will be available in the stalls. Thanks.
Thanks, Satish and Haripriya Dio. Before we break, there is one small video, less than a minute video. Karan, please. This is by our gold supporters, EPAM. Thank you all. We can now break for lunch. Once we are done with the lunch, one important announcement. We won't be meeting in the main Audi here. Instead, for the industry track, we'll be meeting at the central campus's 10th floor. The room is Sky View. So now we'll move to central campus basement to have a lunch at the gourmet. Once done, in the same block, we go to 10th floor to continue our